going to talk a little bit about next 58 minutes around event-driven autoscaling for specifically serverless Java. And I got one question, actually two questions today. So how many people actually have some experience to deploy your application into Kubernetes? Wow, awesome. And then how many people actually try to deploy your application as a serverless platform, for example, Amazon Lambda? Okay, interesting. All right. So, where is the clicker? Okay, here we go. So, yeah, just about myself, my name is Daniel. I'm working for Red Hat. I'm based on Boston, United States. It's a pretty long journey. So, I actually came here several times in Bangalore, and then just 2 times New Delhi for like some IT stuff. And then whenever I came here, it's every time the city is really changed. So when I arrived on Monday morning, it's after almost 20 hours flight from Boston, Dubai, and here. And then when I got here, like 3 a.m., and then got hotel 5, and then woke up early morning from the jet lag, and then I just go around the city, and then there are big, like a tall condo and apartment, and then shopping mall, which is really cool. So I'm working for the developer advocate with DevRel, and then specifically cloud native runtime, for example, Spring Boot, Quarkus, and then like a bunch of the Java technology, like some data grid and a single sign-on, and then like a JavaScript as well. I've been spending a lot of time bringing more Java application into cloud, aka like a Kubernetes. Because one of my job, my responsibility is a CNCF ambassador, which allows me more evangelize many, not only developer, but also like a platform engineer and like a SRE, how do they build a cloud native runtimes, architecture, and the platform, etc., like accelerate their business capability and so on. So here's my stuff here, and then here are some book as well. I'm writing some new books, by the way. And here's my contact information, Daniel030. You can follow my Twitter, you can subscribe my YouTube channel, and then like a GitHub repository, and then you just steal whatever you want. Okay, so here we go. So you already handle a lot of people, and then here is just the auto-scaling architecture with Kubernetes. So one of the beauty of the Kubernetes, you don't need to care about scalability. Based on like the resource utilization, for example, CPU memory, the Kubernetes automatically scale in and out your application based on incoming network traffic. Traditionally, your colleague, like some IT operation team, they need to handle that kind of thing, like needed to buy new CPU, memory, disk storage, things like that. And then a lot of changes that after 2013, 14, some container technology, Linux container technology came out, and also Kubernetes came out. It totally changed that. So this is some architecture. So by the way, I didn't know, so we're going to use the 4:3 ratio format presentation. It's pretty old. So I actually made it a 69, like a page size. So maybe you a little bit like some not good resolution, this diagram. So this is a Kubernetes. And then, as you know, we can deploy multiple microservices, not only Java, but also JavaScript, Python, Go, whatever you want. And then each application runtime serves business services. For example, this is a retail application. You have an inventory, catalog, and then order, and then things like that. And then each microservice application can be running on one single pod. And then Kubernetes provides the horizontal pod scaler, aka HPA, which allows you scale in and out based on CPU memory utilization. So this is a known auto-scaling architecture on top of the Kubernetes. However, in the reality, it's not the same. As you can see, there are external services. For example, like if you use a cloud like Amazon, you could have Amazon CloudWatch, and then you could have maybe reactive programming for like a distributing services like a Kafka cluster. You can have more like if you wanted to run your application Azure cloud, you might have the Azure monitor for coming like a memory, like metrics data, things like that. And then there are also metric-based autoscaling based on Prometheus as well. So how do you handle your autoscaling capability with external services? So this is just some known knowledge and the practice. You can create custom metrics, as you can see here. You can have the custom metrics, like some custom resources on top of Kubernetes, and then you can create like a cloud, AWS CloudWatch metric adapter, and then like a Prometheus metric adapter, and then like a Azure Monitor metric adapter. But there's no custom metric adapter directly connect to Apache Kafka. So that's why you're going to liaison between Apache Kafka and Prometheus. So the problem is with this architecture, you can only enable one single custom metrics in single namespace. So let's say you already deploy multiple microservices on the one namespace, which is like a retail services. And then each microservices can be scaled in and out based on different external services. For example, my catalog application should be scaled in and out based on Kafka messaging. However, my payment actually scaled out based on some kind of metric from Azure Monitor. So this is just some kind of combination or a possible scenario autoscaling architecture with the Kubernetes. So that's the KEDA actually came out to solve this problem. So KEDA literally just acronym Kubernetes event-driven autoscaling. It's a super simple. You don't need to change any kind of Kubernetes YAML file. So one of the big challenge for individual developer is to develop YAML file to specify Kubernetes manifester. I've been there more than like 10 years to generate and create a Kubernetes YAML file. Some people said, it's pretty much similar to JSON format, but that's not true. You need to figure out all YAML specification and indentation and a lot of some the key end values. So that's not easy for a developer. And then you don't even care about that. You don't want to. Because my job is I just develop my code, right? Writing code, Java application. And then I just test based on my unit test, and then just push the code like a GitLab, GitHub, and any kind of source control repository. That's my job. I'm done. And then the next job is like a DevOps engineer, SRE, or platform engineer. They need to care about testing or integration and then deploy to multiple target environment like a production and staging and the testing server, etc. So that's the big challenge for developer. They need to extend their responsibility from inner loop to really bit outer loop as well. Because the Kubernetes is a standard environment to deploy your application, including containerized application, like some container image, and deploy your application Kubernetes. You need to make sure satisfy your functionality features running on Kubernetes, not only your local. So that's why you need to save your time to inner loop process and then give some spare time to outer loop. So the KEDA actually solves some of the challenges because it's very simple. Once you develop YAML file, you don't need to change anything. And then Red Hat and Microsoft actually put a lot of effort and time to develop the KEDA project. And then we have recently, like in a couple of months ago, released to 10 and a bunch of the capability. And it's all one of the CNCF project as an incubating project. As you can see, there are a lot of autoscaler objects, scaled object provided. So you can easily create a scale object targeting which Kubernetes resources, for example, deployment and batch job, you're going to handle scale in and out. So here so some more evolved design architecture. How do we change our autoscaling architecture on top of the Kubernetes with the KEDA. As you can see here, there's no more autoscaler here. You can see here, you could have a scaled object to map to each microservices on top of the Kubernetes. However, in KEDA, actually place your custom metric adapter, and then you can enable multiple metric data, the external services. I'm going to enable my payment services to Azure Monitor. I'm going to enable my order services to AWS CloudWatch, and my another application mapped to Apache Kafka for reactive programming, and like maybe try to process millions of records in the next 10 minutes. And then it's a little bit smaller, but so here is the key feature of the KEDA. So KEDA only handle like a scale 1 to 0 and 0, 1. That's it. However, in production, you might need to scale out more than one pod, like maybe 100 or 1,000, even maybe million pod based on incoming network traffic. That's why KEDA actually invoke existing the HPA, the Horizontal Pod Autoscaler, which allows to your application scale out to like unlimited, as long as your worker resources on top of the Kubernetes around that. So this is a simple example. So how do you create KEDA capability on your application scalability? This is you can create a scale object. The right-hand side is pretty simple. I'm going to showcase the live demo in a minute. So you just specify which is my targeting Kubernetes resource like a deployment. And what is the trigger? Kafka source, or like a Prometheus, or like a AWS CloudWatch and Azure Monitor. There are many of external services that can be triggered. So as our topic today, so what about the serverless autoscaling? So this is another CNCF project, Knative. How many people actually heard about the Knative project? One? Perfect. Yeah, I got to accept the challenge today. So the Knative project, it allows you to manage your application pod just like a serverless behavior. So for example, so the serverless is just deploy your application like a serverless platform such as the Amazon Lambda and Azure Function, Azure Google Cloud Function. And then once you deploy application running on all the time, however, if there is no network incoming traffic, your application just hibernated, like scaled down to 0. Nothing in there, no resources consumption. And then after that, you got some new network traffic, it goes up automatically. And then it takes some time, like a couple of seconds, based on the cold start strategy. So that's the serverless. So why we think about serverless? Because once you investigate and analyze your application workload for the like a past 3 months or 6 months, you know that, oh, my whole application don't need to run all the time like a 24/7 because there are some network traffic trend. Okay, this application only invoked maybe like a 20% of the month because this application not the main page or the main RESTful API. So how do we save the resources, the cost, some money, and then the maintainability? So that's why serverless technology came out. And then whenever I talked about Knative and KEDA, so it's a similar pronunciation as well. So people ask me, hey Dan, what is the difference between KEDA and Knative is? And also, should I choose one of them to enable auto-scaling capability on top of Kubernetes? Because I don't want to deploy my application Amazon Lambda because I already have a Kubernetes. And I also needed to same serverless capability and behavior on top of the Kubernetes. But I don't want to use EKS or AKS. I want to keep using my on-prem Kubernetes. That's why, okay, maybe that's we did that. So Knative project could be your best bet. However, they also very interesting KEDA project as well. So do I choose one of them? So I'm going to show you what is the best answer today. However, here's some bullet point to just to figure out what is the difference between two projects. The one is the main difference is KEDA project. You don't need to change anything on existing running Kubernetes resources. So you just point out which running resources I need to scale in and out, which means you don't need to change the existing custom resources. However, Knative, you need to create a new Kubernetes resources, which is Knative services. For developer standpoint, you need to write new YAML file to do that. And then Kubernetes Knative is like a pushy strategy, and then KEDA is like a pull strategy. I'm going to show you what it looks like. And then today, I'm going to give you some more time, live demo, rather than some boring, like a slide deck. I don't want like that. So the first use case here. So this is a known autoscaling architecture. Here is my application running on Kubernetes. I'm going to use a Java application. I'm a Java developer advocate. But I'm going to use Quarkus today. I'm going to explain why I need to use Quarkus today rather than the other Java, like OpenLibrary or Micronaut Spring Boot. So I'm going to talk about a little bit more. And then I'm going to use external services at the Apache Kafka for like maybe millions of the messaging streaming or messaging storing. And also I'm going to use the Kubernetes cluster today. So here's a simple, the first use case here. As you can see, my application, I'm going to deploy my application, and then I'm going to consume that messaging from Kafka cluster, and then I'm going to create the HPA, and I'm going to give it some time, and then when my application actually scale out based on HPA, and then how fast, and then how many container will be scaled out. All right, let's get into the demo. And then I'm going to bring some stickers today, by the way. So this is a really nice theme, or the Quarkus theme. And then, so we actually created a new Quarkus sticker here. So literally like some guitarist, like a Guns N' Roses and then the Jimi Hendrix. So we're going to try to make developers' life happier. So just like for fun. And then, okay, let me try to start my presentation. And then I actually created two projects in this morning. And then, so here's my first application. It's the Quarkus, the race version here. You can see 2.16.6. So we actually release Quarkus 3 later today or tomorrow morning. So Quarkus 3 actually provides a bunch of the awesome features. For example, we integrate project room to manage virtual thread for reactive programming. We also support microprofile 6, and then we're going to support Jacquard EE10. You cannot find the Java X package on your application anymore. And then we can also provide some Linux kernel integration programming. You don't need to use JNI. And also, we're going to integrate some more low-level network programming, like you could use UDP protocol rather than TCP for high performance, things like that. And then we're going to use Dev UI. It's pretty much more obvious and then user-friendly. And then there are a bunch of the new features coming up soon. And then you can reach out to me anytime if you find more interesting stuff here. Okay, so I actually created one simple application here. So first reason why I use the Quarkus today, as you can see here, is a one simple application, so one void method. And then this method just consume event storing from Kafka topic, and then just print out. That's it. Just one line. Super simple. And then if you have some experience to develop reactive programming with Spring Reactive, and then how do you do that? And then you have already business application, like just Spring Boot. And now you need to change that application more reactive way. How do you do that? You need to rewrite all application Java classes and then like a property, etc. You need to integrate the Spring Boot ecosystem. For example, Spring integration. And then you want to deploy the cloud, you need to integrate Spring Cloud. And you're going to use Spring function. And then the web blocks and mono, and then you're going to change all return type. There are many kinds of stuff. You're going to set it up. And then you can also create a Docker compose, and then you can also create Kafka, the initializer, things like that. It's a more pragmatical way. So there are a lot of things you need to do, and then you don't even understand how reactive programming works if you don't have any enough experience. So the Quarkus actually was born as a reactive engine, which is Netty and BirdX. But Quarkus also provides a capability for developer. You don't need to develop all the way as reactive programming. You can also develop non-reactive programming. How do I do that? You just needed to add the relevant Maven dependency or Gradle module, which Quarkus calls extension. You can also need to relevant annotation on top of the method and on top of the class. For example, you can see here incoming annotation, and then the parameter is actual topic name from Kafka cluster. With that, so this method automatically consume messaging from Kafka cluster and then process just like a JSON format. So when I go to my application property, now you can see where is my Kafka cluster with the topic. So as you can see, here's the incoming, and then here's my topic name, my dash topic. And also, where is my Bootstrap server here? This is my Bootstrap server, because I'm going to deploy this application eventually to Kubernetes. So that's why I'm going to use the Kubernetes service name as a Bootstrap server URL. If you want to point to some Kafka server in somewhere out there, Kubernetes, you're going to use a fully qualified domain name or IP address or whatever you need. You could just put in here and a relevant port as well. So, and then the second reason I wanted to use Quarkus today. So here's the Quarkus OpenShift extension. When I go back to PalmXML, and then here we go. So we already add the Quarkus OpenShift extension. So which allows, I'm going to put in some extension here, key and value. So when I put in some a Kubernetes key and value, like a Kubernetes deploy true, and the target is I'm going to use OpenShift. OpenShift is an enterprise Kubernetes version by Red Hat. You can actually set it up target equal Kubernetes or target equal Knative. And then when you build this application like a Maven package or Gradle install, it automatically generates that YAML file, like a Kubernetes YAML file. So developer, you don't need to worry about how to write down Kubernetes YAML file. The Quarkus automatically make that happen. And then you don't need to use Docker or Podman CLI to containerize the application after you create the job file. And you don't need to run kubectl to apply for this YAML file, because Quarkus automatically take care of that for you. So that's the reason why I'm going to use Quarkus today, and the second reason here. So let me go to my terminal window, and then for that, here's my OpenShift cluster. And then I have the first project, Kafka HPA. I already create a Kafka cluster using operator. And then back to here, let me try to a little bit bigger for you guys. Okay. And then I'm going to try to make sure I'm logging in the right project, the Kafka HPA. And I'm going to try to build new application. So you can use Maven, Gradle, whatever you need, and I'm going to use the Quarkus CLI. This is the third reason I'm going to use Quarkus today. So Quarkus provides CLI command line, because one of the challenges for developers, including me, I don't remember any old parameter, like some option when I run Maven command line and Gradle as well. Whenever I try to not just a Maven clean package or like a Maven clean package or install and a -d and some of the options. In order to that, I just found like a Google Ring. What would you say you're going to ask the GPT chat? And then he answered that question. However, the Quarkus CLI provides automation, and then you can easily add like extension, and then like a build, deploy, and then like a bunch of stuff. You can easily use that. You can install Quarkus CLI like a JavaScript, which is a JVM, or if you use a Mac OS just like me, you can use SDK man or the Brew packaging manager, and then you can use a Linux operation like a Fedora, and then Ubuntu. There are some binary downloadable file as well. So it's too big, but behind the scene, Quarkus actually packaging a job file, but we're not going to say Uber or Thinja, because the Quarkus framework overrides Java class loader, which allows to reference to existing Java file path and library, and then it should make it a little bit faster startup time. That's why Quarkus calls that fast jar. And then packaging the image file. I've just done. Hopefully good Wi-Fi internet. Okay, let me go back to my here we go. And then as you can see, here's my Quarkus application. Let me try to a little bit bigger. Okay. Go to the application bureaus, and here's the Quarkus logo. And then try to see I access to my topic. And then the other one is a Quarkus version, just like the same 2.16.6. And then there are a bunch of the extension I already edited. And then back to here. And then the wonderful thing is when I deploy application, you can see the pod, and then you can up and down arrow, which means you can scale up and down manually, not auto scaling stuff. So let me try to add auto scaler here using like a OC command line. You can use the kubectl as well. I'm going to set it on min-max 110 and CPU utilization 70%, which is a more reality use cases. When I go back to UI now, you can see auto scaling pod is set up. They're just gone, or the up and down anymore. And then let me go back to my application, and then I already added some batch job. So Kafka cluster actually including the performance bash script here, the Kafka performance the test script. I'm going to using this one rather than some third-party tool. I'm going to put in my topic, and then I'm going to create like a 1 million dummy record every single second here, and then it's going to be 5 parallel pod for the batch job. So I'm going to copy, and then you can use the kubectl for apply this YAML file. And then one of the beauty of the Apache cluster, you can actually have the GUI feature to import YAML file. And then when I go back to the topology view, and then here we go, the new job file just created in a file. When I go to click on one of the view logs file, and then now you can see the dummy record automatically generate every single second. But it will, you feel it's more than 1 second because there's some time to rendering in the view logs. But inside the Kafka topic, it's literally generated one event message every single second. When I go to check it out, the Quarkus log, and then what Quarkus is doing right now, as you can see, is super busy, like going crazy busy. One application needed to process 5 million for the next couple of minutes. And then when I go back to topology view, and then here we go, and then here's the HPA. As you can see, it's a 70% target. And so HPA takes some time to figure it out. Okay, so when my application scale in and out, it takes some time. I would say Kubernetes HPA a little bit like a stupid. It's not smart because I have so many events streaming and stream data coming to my application, but my application is going to be crazy. However, the HPA even doesn't know that. It takes some time. That's the I really want to say the HPA is not fitted in the event-driven application. Today I'm going to use Java because you guys most likely Java developers. However, you are more like a .NET or Python developer, all the same. Okay, let's give it some time for like some not smart HPA folks. And I'm going to change it. I'm going to back to my slide here. And then, so how do we redesign and then improve this autoscaling architecture? So let's try to give it a try, KEDA. So this is some new architecture, how to KEDA make our autoscaling architecture better. Now you can see the right bottom, you can see the KEDA here. KEDA actually put together all metric data from Kafka cluster. Just this is why I'm going to say pooling strategy. In the meantime, your application, for example, Quarkus, keep consuming metric data, and then some time later, KEDA, okay, now it's the time to scale out, and then ask to Quarkus application. This is a really better architecture. Let me show you how fast and how many applications scale in and out. Let's go back to the demo environment. So first of all, I'm going to change namespace here. So my application still one, and then there's another project. Let's go to Kafka KEDA here. Kafka KEDA. And then also I just install Kafka operator here. And then when I go back to my working project, actually I have YAML file just in case I don't need to rebuild. I don't need to rebuild because I already built images. That's why I already pushed that image into like a Quay container registry. You can push it, this container, your own container registry, like Google Container Registry, Azure, or like a Docker Hub, whatever you want. And then I just need to deploy my Quarkus application first here. And then application deploy. And then let's take a look at the application inside just to make sure the same application like a 2.16.6. And then I connect to my topic channel, which is cool, and back to here. And now go back to working project. And then like I mentioned earlier, I need to create a scale object, which allows me to scale in and out my application, targeting application. So what is my scale target? As you can see here is the name Quarkus-EDA demo, which is literally same name my deployment. So this is, I don't need to change any kind of Kubernetes resources. And then what is the trigger? Today we're going to use Kafka cluster. That's why I just using my Kafka, and then the topic name is literally same. And then as you can see, my application is like a same up and down, not auto scaling, set it on right now. But when I create a scale object based on KEDA, and then back to the topology view, you can see it auto scaling automatically enable. And then you can also see HPA automatically created by HPA, the KEDA. So this really, the KEDA make it easier and super simple for auto scaling. So now let's try to run that batch job for the performance test again. So I'm going to using the same job. And then I'm going to share the whole example, my GitHub repo. You can find my whole this example YAML and application file on my GitHub repository. Okay, so back to topology view, and then my batch job now starting, and then just try to create a new dummy record. And then it really takes some time to KEDA actually decide that this is the right time to scale in and out. So let me try to go to the batch job. One of the pod, it actually generate the dummy record. As you can see, it's creating a new one every single second. And then back to the application topology view. Now you can see my application Quarkus scaled already to 8. The max is 10, the same capability. And then go to one of the Quarkus application, Java application, you can see it also creates busy. But it's not much crazy, just like the HPA stuff. When I go back to the previous namespace and then take a look at that, it actually scaled out right now. And then you can see the job is done already. However, I have only 2 container pods because when I take a look at HPA, and HPA said, okay, so targeting 70%. I just figured out, okay, realization, CPU realization is like a 79%, which is, okay, I'm going to scale out one more part. But it's really not real processing and analyzing event storming. So that's why, and it takes some time to scale out. Maybe in the meantime, your application maybe got some out of memory error or some leak of the memory resources, something like that. And then back to the KEDA. And now you can see your Quarkus application already scaled out to 10. So go to here, and then you have a 10 Quarkus application already scaled up. It's a little bit faster than just normal HPA application. This is really how to redesign and improve your auto scaling feature. And then back to but this is not the end. So let me give you some more opportunity. What is the more improvement stuff here? Just like a Google interview question. Is your best shot? Is there any other way to optimize or make it better, your application code? You can say yes, but you don't know how to do that. So this is the answer for you. So I'm going to use more serverless stuff here, put in the KEDA, Knative actually, and then it's pretty much complicated rather than previous architecture. What is the big difference thing here? You needed to have a Knative eventing infrastructure as a between Kafka and actual application. As you can see here, it's working, yeah. Anyway, so Kafka source, it allows you to get rid of your the Kafka information, for example, Bootstrap server, and then put in that customer resource, and then it actually have a parallel connector between Kafka cluster and targeting application as a liaison. And then one big different thing between Knative and KEDA. So Knative actually they has own autoscaler, not using HPA, and then it actually asks directly application to scale in and out. That's why I'm going to say Knative is using pushy model rather than pull strategy. So let me go back to the application demo environment. So first of all, I'm going to change my namespace again, just like no application here, like a Kafka Knative. And then back to the project. This is my second project. And then you can see that I needed to actually rewrite my application to using cloud event here. So as long as I'm going to use Knative eventing, I need to change my application to process cloud event for messaging processing. Because you got some issue. Some of the application using JSON format for messaging processing. So the other application using binary. And the another one is using something like product buff. So how to integrate and transformation among the other messaging format. So cloud event actually gives some standard way to define the messaging across the multiple different types of event infrastructure and application. I don't have any business logic at this moment. That's why I don't have any code to process cloud event messaging. Instead, I just print out just like the same existing previous application. When I go to application property, and then I don't see any kind of Kafka configuration like a Bootstrap server configuration because I'm going to create the Kafka source based on Knative stuff. And then one thing is, different thing is here. So previously I was targeting to OpenShift, which allows me to generate OpenShift YAML file. Now I'm going to use it to Knative. So when I go back to that application project, and under the target directory, it automatically generates Kubernetes directory, and then you can see YAML or JSON. It automatically generates this is a Kubernetes resources / OpenShift resources. That's another reason I just mentioned about Quarkus automatically generate this kind of for developers. So with that, when I just set it up, Knative here, which is the automatically generated Knative YAML file. And then image group actually is a Kubernetes namespace. So Kafka-Knative. So that's why I go back to here, and I'm going to use the same Kafka-Knative. Okay, so let me go to change my directory, Knative, and also change my project, Kafka, KEDA, and Knative. Okay, so now I'm going to build my application once again, and then it automatically generates like a Knative YAML file rather than Kubernetes or OpenShift YAML file, because I'm going to deploy this application as serverless at this moment. When I go back to the application project, so Quarkus actually automatically generates Docker file as well for JVM and then also legacy jar. As I mentioned earlier, Quarkus by default generates fast jar, which is not existing just right after the target directory. It actually two-level layer under the target, under the Quarkus-app directory. However, sometimes you want a packaging jar file, and then some platform only refer to some jar file right under target directory. In that case, you're gonna set it up my packaging type like a legacy jar, which is like a Uber or thin jar, and then you can generate that jar file. Because when you go to Docker file JVM, you can see here, here we go. So target / Quarkus-app / jar file. However, when I go to legacy jar, it's literally your traditional jar file, like under the target directory and a jar file. And the Quarkus also provides native compilation running on GraalVM, which is to make it super fast. For example, when I created like a few of RESTful API and running on job like a fast jar, it takes like a 0.3 seconds rather than half a second. But when I packaging native executable with the same application, it just takes like 11 milliseconds in almost like a 10 times faster startup time. So and then let's go back to terminal and then just finish that my build. And back to the application, let's go to our target tree. Now you can see here the Knative YAML file you can have right now. So back to my project. Then should I? Oh, actually I got a wrong project. Okay, let me try to one more time. Kafka and Knative, and then I'm gonna build once again, and then let me try to clean up because another namespace, the Kafka-Knative, KEDA Knative, I'm gonna deploy to some the last optimization stuff here. So let me try to delete existing one, delete services. And I'm going to switch it to administrator to delete the other stuff like a build configuration and also image stream. So my application, I'm using Open Java 17 right now. So in order to avoid the conflict when I deploy the next application, and then I just delete it all. And now you can see here, it's just empty. And then let's go back to the right project namespace, Kafka-Knative here. Okay. So back to the terminal. And then as you can see, it actually creates a jar file first, and then containerize the application. Like as you can see, there are image containerization, and pulling this image into targeting container registry. So OpenShift cluster actually has own integrated container registry based on like a Quay. So that's why I'm going to use that kind of stuff. But you can actually push any kind of container registry. And then, as you can see, it's the imaging, containerized imaging based on Docker file already generated inside the Quarkus project. And then we're going to push that image and then Kubernetes automatically deploy this application into available worker node. And go back to MUI. Now I got a new Quarkus application. It's coming up soon. And then try to view logs. Just to make sure I'm going to do the same application, same version, because I'm going to keep doing performance tests here, 2.16.6. And then back to the topology view. So default configuration of Knative for scale down to 0 is 30 seconds. So let's give it some time. It will scale down to 0. And then I'm going to run the same performance test tool, bash script, and then it will scale out automatically. So let me give it some, add one fun stuff here. I'm going to add a label, which is the Kubernetes feature, runtime equal Quarkus. So because you sometimes deploy many applications, just like an online retail project, like order, payment, and inventory, catalog, and then some of the application based on Java, Spring Boot, Quarkus might cannot, and then just hold your Java class or .NET, Python. So this topology view allows you give some distinguished icon for each application, which allows you identify the runtime environment, literally and right away. As you can see, in the meantime, the application pod is terminating, and then it will just goes down in a soon. And after that, let me go back to project, and then I'm going to run. But for that, I just needed to Kafka source, which is Knative eventing. As you can see, I'm going to target what is my bootstrap server. It's a literally Kafka bootstrap server. I actually got rid of from application property, my application side. And now I just created this resources based on Kafka Knative eventing. And also, what is the targeting topic here? And then the sync means where I need to put this messaging from Kafka and then into some of the application. That's why Quarkus-EDA Kafka demo is literally the Knative service name. When I go back to here, it's literally the same name here. So let me try to create the Kafka source and then back to the topology view, and you will see your Kafka source attached automatically. And my application gone, as you can see here. There's no pod is running right now. And then back to the application. And then I'm going to try to create the same performance test here. Okay, here we go. And then once you create 5 pod as a batch job, and then it automatically generated dummy messaging storming like 5 million. And then as you can see, my application automatically just go up, just like a serverless behavior like Amazon Lambda and Azure Functions. And I go back to my application property, just like it's super busy to process like millions of data. However, it's not going to scale out to more than 1. It's always 1. There is some problem with event-driven applications, serverless with Knative. And the last namespace is Kafka KEDA Knative. So let me go back to slide one more time. So how do we handle serverless autoscaling? But that's not enough. More like event-driven serverless. That's why we got another chance that we have a sandbox project, integrate Knative project and KEDA. You don't need to choose one of them right now. That's my answer at the very beginning I asked and I shared. So there are sandbox project and the Red Hat and a bunch of the other vendors give some effort to create this new sandbox project. You got some multiple benefit from Knative and KEDA at the same time. So currently KEDA actually control Knative eventing infrastructure in this demo Kafka source. And then that Kafka source scale out based on KEDA. And also, in the meantime, Knative also scale out the application more than 1, like 100, 1,000, whatever you need. So this is the last architecture we're going to optimize and make some awesome Kubernetes autoscaling. As you can see at the bottom, you can see Knative and then KEDA. So there are two layers actually automatically, simultaneously autoscale, not only application, but also the infrastructure layer, which means it's pretty much faster than only using Knative and KEDA, but also flexibly scale in and out based on real-time messaging traffic. So let me go back to demo environment. It's a Kafka, KEDA, Knative. And I'm going to make sure, change my project. Kafka, KEDA, and Knative. Okay, oh. Yes, typo. Okay. Oh, once again. Kafka, KEDA, and Knative. Okay, we have a live project, and then once for that, I just changed namespace, which means when I go back to application property, I need to change the image group, which is a namespace, and also I need to enable the Knative compilation. This is the last reason why I'm going to use a Quarkus today. I'm going to set it on key and value, specifically Knative, like a min-max 110 and 0, actually not 110, actually scale down to 0. If you process all network traffic in the end, so just save a file, and I'm going to build application once again. And then back to my project, and then I'm going to create the Kafka source again, but in this case, based on this integration sandbox, now I can add some annotation here, the KEDA annotation. So this allows me to use KEDA Knative at the same time to manage my autoscaling, not only application, but also the intermediate, the Knative eventing infrastructure as well for my Java application. You can use this kind of stuff, any other Java framework, like Spring Boot, the other stuff, but you cannot set it up your application side. You can need to create the whole YAML file and then the separate configuration at all. So I just copy that kind of thing. When I deploy that, let me try to maybe create a layer. And then it automatically attaches once my Quarkus application is deployed. So back to the terminal, and then it will take some time, a little bit more. And then I'm going to just to run this batch job one last time. And then just copy container image, and then it will be finished soon. And then push that image again to containerize in the right, the namespace. So now push the application. And it automatically, you can see the Knative application actually deployed there. Okay. So now I got the new Knative application, attach new Kafka source, which enable KEDA and Knative enablement. And give me some time to scale down to 0 again. In the meantime, I'm going to try to do the same thing to make sure this application on Quarkus. And then it will scale down to 0. So let me go back to, I have a few more slides here. So give it some try to summarize this talk today. So you can also use not only Kafka source to integration KEDA Knative. You can also using AWS SQS source and the Redis stream and also RabbitMQ. So more choices to use this integration, more optimized autoscaling feature. And then once again, KEDA is super simple for event-driven, but not couple of serverless. And then KEDA just pulling your metric data and then ask to your application, scale up and down. And then Knative actually literally ask the application directly rather than like a pull model. That's why the push model stuff. And then currently, this KEDA Knative integration project handle KEDA eventing infrastructure, for example, Kafka source. But we got some roadmap to cover this integration just directly to ask Knative servicing, which means we got to get rid of one layer again, which is pretty much faster and then dynamical stuff. Okay, so let's go back to here. So application is gone. Let me try to run the batch job one last time. And then here's a batch job, just create that. So let's take a look at my application here. And then just like using Knative, it will go up soon enough. And then after that, Knative actually scale just once. But this is going to be scaled more than, as you can see, it's automatically scaled to 4 really fast rather than only using KEDA and then just not one like a Knative. And then when you go back to like a Knative project, and then it will be still just one part, and even job is done, however, it's still one. So that's the problem. And then back to the KEDA Knative, and then it's actually a more dynamically processing real-time event messaging. So previously, KEDA actually scaled up to 4, and the right away to up to 8 and 10. But it's actually keep monitoring. Okay, it's just, because in the meantime I scale up, but in the meantime I keep working to consuming that data, which means I don't need to scale more 4, 8, and 10 right away. So that's why it takes some time, and then so literally up and down pretty much flexibly. Okay, I am running out of time. So I have 2 more sessions today, today and tomorrow. So today, 4:30 p.m. So I'm going to talk about a little bit more real-time processing, like Apache Pulsar with my colleague, my friend, Mary. And then tomorrow I'm going to do more 1 hour, it's 100% live coding demo stuff, how to create your Java application, Kubernetes Java stuff. So here's my YouTube channel. Feel free subscribe, and then I already put in more than 200 demo video. You can find actually the demo I showcased today in my YouTube channel. And so feel free, watch that and ask any kind of question. And also you can ask me, hey Dan, I need to run something new around the new technology. And then I'm more than happy to create that project. And then when I go back to here, and you can see it's literally automatically up and down, more flexibly, dynamically. That's all I have, and thanks for watching today, and thanks for joining, and hope you enjoy the rest of the summit. Thank you.